So the problem here is this. You're given a 70 kilogram crate, and we've got two forces pulling on it, 50 Newton force and an unknown force. We know the object is accelerating to the right at 2 meters per second squared. So let's draw a free body diagram of this. Tell me what the net force is on the object and what must be the value of F2. So let's solve this. So the first thing you want to do is draw a free body diagram. So here's our object of interest. So just draw it. You can put the wheels on it if you want. And then, well, what are the forces acting on it? Well, we've got gravity pulling it down. This is the force of the Earth acting on the cart. Now, if you take physics, you'll know that this is F sub g for gravity. And if you call it F sub g, and the little g stands for gravity, that's okay. Or you can call it the force of the Earth, pulling it down. Then you got the ground, these two surfaces right here, the surface of the ground and the wheels pushing up on the cart. Now really, there's probably 4 wheels on this cart, but we just draw it as one force just to make the drawing easier. So this is the force of the ground pushing up on the car. Okay, now in physics, those of you who had physics, we call this the normal force. In physics, we call this the force of gravity. As long as you know what they are and what's going on, that's fine. I don't care what you call them. And then we've got this F2, and then we've got a 50 Newton force like this, which is F1. And that is my free body diagram. Now, what is the net force? So this is part A. Another way I would grade this, probably a point per force correctly labeled in the correct direction. Then for part B, well, the net force equals the mass times the acceleration. The mass is 70 kilograms. The acceleration is 2 meters per second every second, or meters per second squared. Therefore, the net force is equal to 140 newtons. We also know that because the acceleration is positive, meaning to the right, we also then know that the net force is to the right. Now, the net force is also equal, well, let's just not even worry about these two forces because they cancel out. We're just going to look in this direction here, in the x direction, and we'll say, well, the net force is what you get when you add the two forces together. So I'll call this F1 plus F2. So we can solve for F2. So F2 equals the net force minus F1. And so F2 is equal to the net force, well, that's 140 newtons, minus, now here's the trick. Here's a little tricky part. I told you this is 50 newtons, but what direction is it in? It's to the left. It's to the left. So really, if we say that to the right is positive, to the left is negative. So really it's minus negative 50 newtons. And what happens when you subtract a negative number? It's like adding. So F2 is going to be equal to 210 newtons. So you really got to pull on it. Okay. Or, oh, I'm sorry. What did I get? Oh, jeez. No, I was just testing. You know, remember, people, question authority, especially if I'm the authority. All right. So 190 newtons. How did I get that? All right. Now, then you ask yourself, hey, does this make sense? Look at what F2 has to do. F2 has to supply enough force to accelerate this thing to the right, plus enough force to cancel out the 50 newtons. So to cancel out the 50 newtons, I got to pull 50 newtons to the right, and then to accelerate it, I got to pull it with 140 newtons to the right. So I add those together and I get 190 newtons. Okay, do you see it conceptually as well as this? If you get too lost in the math, sometimes it's really easy to drop a negative sign or do something. But if you think about what's happening in the real situation, if you visualize it, that can quite often get you through it. Okay? So ask yourself, can you do this on a little quiz? If I gave this to you, a problem like this again, would you be able to do it? Okay? We'll find out. Any last questions? That is all.